Hello friends, in the next video lecture of computer graphics, I am going to explain the fifth type of 2D geometric transformation known as shearing. So shearing, in the case of shearing, we are going to distort the object size, but the volume and the area is going to be remain same. So what is actually shearing is known as, and how the shearing is actually introduced, or the how the shearing will be explained. We are going to be see that. So start with the shearing. So before going to explain the shearing, we have to know these two terms, that is called rigid body and affine transformation. What is exactly these two terms are, that we can see that. So a transformation matrix, basically we have know that the translation, scaling and rotation all have 3 by 3 transformation. In this three transformation matrix, we can see that upper this particular sub matrix having some effects on the objects. So here is you can see that the upper 2 by 2 submatrix I have mentioned here. This red color box is an orthogonal and prism angle. That is the main thing, is prism angles, and the length means that whenever we are applying these elements on the point matrix or point, so that the angles and the length are prism, means the changes of the angles and the length are not going to be happen, means they sustain. So such transformation called rigid body transformation means that the object is going to be shifted from one place to another place without any changes in angles or its length, means its size. So this type of transformation is known as a rigid body transformation, means size is not going to be changed, because the body or an object being transformed is not distorted. Same thing is, I have already told you that the distortion of the object is not possible in this transformation. So an arbitrary sequence of rotation and translation matrices creates a matrix on the forms. Means the example is that rotation and translation, if you apply on an object, so rigid body translation can be possible only, and the scaling if apply, that is known as another type of terms, that is called affine transformation. So how the scaling will be produced in affine transformation, you can see that the product of an arbitrary sequence of rotation translation, means rotation and translation give the rigid body transformation, but when you apply this scaling matrices will cause an affine transformation, means this scale transformation actually cause the affine transformation. And if you release this scaling, means if you not consider this scale, then rotation and translation is actually known as a rigid body transformation. So you know that very well, that what is exactly called a rigid body transformation and what is exactly called an affine transformation. Affine transformation means the size and whatever the size and the angles is going to be changed, that is known affine. So which have the property of preserving parallelism of line, means the affine transformation going to be happen, means that the size is going to be changed, but the parallelism of line means that the line, whatever the line will be parallelism, means if the line is parallel before the transformation, then after the transformation, means scaling is performance, the after the scaling the parallelism is also sustained. So but not the length and the angle. So this is known as a, so parallelism is there, so means properties that, but not the length and the angles. So we have to be preserving that called affine transformation. So you can see that here unit cube is there. So when you apply the rigid body transformation, means some angular movement is there or some shifting is there, so you can see that the size and length in all the directions are same, but the movement is there. You can see that it is moved, means this edge is you can see this vertex is going to be shifted here. So you can see that it is moving, vertex is moving, edge is moving, but the length of the edge is same and the angle of the edge is same. But when you apply the affine transformation, then the parallelisms is sustained, means that if you consider this particular line, so both the lines are parallel, so after this affine transformation you can see that again they are parallel, means that the parallelism sustain, but the length and length is going to be increased. You can see that length is going to be increased, and as well as you can see that angle is going to be disturbed. So this is known as an affine transformation. Means affine transformation, parallelism is sustained, means they maintain the parallelism, but the length and the angle is not maintaining. That can be going to be changed in the direction of x or y direction. So this is the case of affine transformation. So shearing is also being called an affine transformation because it sustain the parallelism. You can see that this two lines again is going to be parallel here. So same direction parallelism is there. So these two lines are again parallel. Before the shearing, you can see that both these lines are parallel. Again after the shearing, both the lines are parallel. Same as these two lines are parallel. You can see that these two lines are parallel. So you can see that these two lines are parallel. So after applying the shearing process, the parallelism is maintained, but the angle is going to be changed. You can see that here is a 90-degree angle, but after shearing the angle is going to be decrease, and here the angle is going to be increase. You can see that this is the angle I am mentioned by the two double lines. So you can see that. So angle is going to be changed, length is going to be remain same or change, but the parallelism is maintained. That is known as an affine transformation. Same as in y direction, you can see that parallelism is going to be maintained. So friends, you can understand very well that what is rigid body and what is affine transformation. So now come to the point, shearing in x direction. So here is an object. You can see that after applying this object, when we apply the x direction, so this is going to be happen. So this is the resultant. That means after shearing in x direction, then how it can be possible. So here is some description about that. Y coordinates are unaffected because when the shearing is applied in x direction, then y coordinates are unaffected. Y coordinates value will be remain same. That is not going to be changed. You can see that this position and this position is remain same. So means this height is going to be remain same in both the object. After shearing and before shearing, that height is going to be maintained. So this is known as an y value is not affected, but the x coordinates are translated linearly. You can say that linearly means that with y, means linearly with that whatever the value from bottom to up you are going, in that respect the ratio is going to be increases. So you can see that this area is going to be linearly increases. Means here the value is 0, y value is 0, so that there is no linear effect is there. When you are gradually towards the increasing size, so that a portion is going to be increases. You can see that. So that is known as a linear increase of the x direction, but the x coordinates are translated linearly with the y value. So that's why it is going to be. So how that can be possible? Here is the equation is there. Y dash is equal to y, that is remain same, that is not going to be changed, but how the x value is going to be changed linearly with respect to the y value, here is the main factor is there. So x is added to this main factor and the value is linearly changed. Whatever the value is y, and the linear factors means factor means you can say that the x direction shearing factor, that is h, is going to be multiplied y, and the result is there. Then how this expression is going to be represented by a matrix. So you can see that this is the matrix. So when this matrix is going to be solved, this equation can be generated. So this is the matrix of shearing in x direction. And now come to the point, shearing in y direction. So if you apply this object, in this object, if you apply the y direction shearing, so that is going to be happen here. So you can see that going to be happen here. So in that case, you can see that the x value is not going to be changed. You can see that the x coordinate is unaffected. X coordinate means this distance. So you can identify this distance is not going to be changed. That is maintained. You can see that this distance is going to be maintained, but the y value is going to be changed. So in that direction, the object is going to be shear, means object is going to be changed or change their shape in the y direction. So how this can be possible? So how they can be linearly increases? Here is the same concept will be taken here, but here the x value is going to be maintained, means they never change, but the y value is going to be changed by this g means the shearing factor with respect to the y direction, and applied on the x, so you get this value. So you can see that how that is going to be changed. So what is the matrix? So this is going to the matrix, you can see that, and when you apply this value or solve this matrix representation, so you will get this point. So here is 0, it's not an O, it is a 0, so you can correct it, it is a 0 value. So this is the equation and this is the matrix representation. So you can understand very well that what is the, so some interesting fact we can see that a 2D rotation is 3 shears, means when you apply 3 shears, so one 2D rotation can be possible. Some interesting factors there, you can check it. Shearing will not change the area of the objects, same as that I have already told you that affine transformation, shearing process is the affine transformation effect, means that the parallelism is going to be maintained as well as the angle is going to be changed, but the length is not going to be changed, because affine transformation define that parallelism should be maintained, second length and the angle is going to be changed, it's not preserved, you cannot preserve the length and angle of the object. But in this case of shearing, the angle is going to be changed, but the length of the side is not going to be changed, means it's an follow the rule of affine transformation but partially follow the rules. So parallelism is maintained and angle is going to be changed. So this is one kind of affine transformation. So shearing will not change the area because the length is not going to be changed, so the area or the volume, you can say that if you take as a 3D geometry, so volume is not going to be changed but area is not going to be changed. So if you distort the object, the area of the object is remain same. So that is the main important point of the shearing is there. And any 2D shearing can be done by a rotation followed by a scaling and followed by a rotation. So first apply the rotation and then apply the scaling and then apply the rotation, you can generate a 2D shearing. So 2D shearing is the combination of rotation, scaling and rotation again. So this is some interesting factors there, you can find out this interesting factor of prove that factors by implementing that. So this is the case of shearing, and now some examples is there. Here is an object is there and we apply the shearing, so that is going to be changed here, or in the y direction that is going to be changed here. So some questions is there, you can perform this question. Here is a question is that other than this type of question, one interesting question is there with respect to any reference line, how it is going to be possible, same as we apply the back translation and then shearing process and then forward translation can be possible. So this is an extraordinary question is there. So some implementation can be measured here, or apply the 3-step process, back translation, shearing and forward translation to solve this question. So friends, thank you for listening this video lecture at the last. If you understand the lecture, then like the video, share the video, and don't forget to subscribe my channel. So once again, thank you.